Start with a quiet observation about how solar stopped being an energy story and became a pricing system China can tighten or loosen like a valve. Build a cause and effect chain where industrial overcapacity, supply chain control, and pricing discipline gradually reveal solar as a tool of economic leverage rather than just manufacturing strength. Unique angle. China's real advantage in solar is not dominance of panels, but control over the hidden inputs and pricing compression cycle that determines who survives globally. Mood applied. Cold and methodical, restrained tone, evidence-led pacing, minimal emotional language, emphasis on mechanism over drama. It's strange how something as clean as sunlight ended up sitting inside trade strategy meetings in Beijing, not as an environmental goal, not even as an industrial success story, but as a pricing structure that can be adjusted until entire foreign supply chains stop making sense. If you track solar back to its physical roots, it looks simple. Sand becomes polysilicon. Polysilicon becomes wafers. Wafers become cells. Cells become panels. But that simplicity is misleading in the same way a balance sheet is simple if you ignore where the leverage sits. Because over the last decade, China didn't just scale solar manufacturing. It absorbed the entire pressure system underneath it. Start with polysilicon, the material nobody outside the industry talks about, but everything depends on. Companies like Tongwei expanded into it aggressively, locking in upstream capacity that sets the floor for global production costs. Then you move into wafer slicing, dominated by firms like LONGi Green Energy Technology, where efficiency gains didn't just reduce cost, they rewired global expectations of what cheap even means. By the time you reach module assembly, the names become familiar. Jinko Solar and others operating at a scale that makes competitors in Europe and the US look like niche suppliers, not industrial rivals. But scale alone doesn't explain the shift. Scale exists in other industries without producing leverage. What matters here is something more specific: synchronized overcapacity. Multiple layers of the supply chain expanded at the same time, not sequentially, but in parallel. That matters, because when every layer expands together, price discovery stops being a market process and becomes an internal coordination outcome. At that point, the question is no longer, what is the cost of solar panels? It becomes, what price is acceptable to keep global production from relocating? And that's a different logic entirely. There's a common argument that China simply outcompeted everyone on efficiency. That's partially true, but incomplete in a way that changes the interpretation. Efficiency improvements alone don't typically produce decade-long global price compression without stabilizing control over input availability. And this is where solar quietly shifts category. It stops behaving like a commodity market and starts behaving like a managed corridor, where the flow is open, but the pressure is not evenly distributed. You can see it in how margins behave. When Western manufacturers exit, they don't do so because demand disappears. They exit because the price floor keeps falling below their cost recovery threshold faster than they can retool. That kind of sustained compression doesn't happen randomly. It requires either relentless innovation across all players at once, or structural asymmetry in who can absorb losses and for how long. China's system allowed both expansion and endurance. Domestic producers could survive cycles that would erase thinner capital competitors elsewhere. Not indefinitely, but long enough to reset global baselines repeatedly. And once baselines reset often enough, they stop feeling like shocks. They start feeling like reality. There's also a less discussed layer: the internal policy rhythm inside China itself. Local governments, industrial subsidies, export incentives, they don't move in perfect alignment, but they don't need to. The effect is cumulative. It produces bursts of capacity that the global market absorbs like repeated pressure waves. At some point, it becomes difficult to separate market price from policy-conditioned price range. And that's where the uncomfortable shift sits. Not in who makes more panels, but in who unconsciously adjusts their entire energy transition strategy around prices they did not set and cannot meaningfully influence. There's more to unpack here, especially how this interacts with Europe's energy vulnerability and the US attempt to rebuild domestic solar capacity under Inflation Reduction Act constraints. But that starts to raise a different question entirely. What happens when the world builds its clean energy future on a price signal it doesn't control? The interesting part is what happens when that price signal stops behaving like a normal market indicator and starts acting like a geopolitical constraint. Because Europe didn't really choose solar at the pace it did, it was pulled into it. After the 2022 energy shock, gas stopped being a stable planning input. Russian supply volatility didn't just raise prices, it broke forecasting models. When that happens, policymakers don't optimize. They rush toward whatever variable still looks predictable. Solar looked predictable. Not because it was stable in a technical sense, but because its cost curve had been collapsing in a straight line for years. That kind of visual consistency is powerful in policy rooms. It creates the illusion of controllability. And most of that curve was being set by Chinese manufacturing density. By 2023, imported solar modules from China were often priced so low that European producers openly described them as non-recoverable competition. That phrase matters. It's not emotional language, it's accounting language. It means your depreciation schedule stops making sense. Now here's the mechanism that doesn't get enough attention. When China compresses solar pricing through scale and competition inside its own ecosystem, it doesn't need to explicitly target foreign producers. The effect happens passively through export pricing. Domestic competition becomes global pricing export. That's why firms like Trina Solar and JA Solar matter beyond their balance sheets. They are not just manufacturers. They are transmission points for a pricing environment that was formed internally and exported externally without adjustment. Europe tried to respond with trade defenses, anti-dumping investigations, tariff discussions, localized manufacturing incentives. But there's a structural problem here that policy doesn't easily solve. You can protect a market from imports. You cannot easily protect it from physics-defined cost curves unless you are willing to permanently subsidize the difference. And that leads to a quiet contradiction inside Western energy strategy. They want strategic autonomy in energy, but they also want the cheapest possible transition pathway. Those two goals only align if you control the supply chain or accept dependency on the lowest cost producer. Right now, those options are not symmetrical. The US approach under the Inflation Reduction Act tried to break that by forcing domestic production through tax credits. But even there, the cost benchmark is still indirectly anchored to Chinese output. It has to be, because global capital compares returns across borders instantly. No subsidy exists in isolation. So what you get is a hybrid system, politically domestic, economically comparative, structurally dependent. And China doesn't need to weaponize this in the traditional sense. There's no embargo, no explicit restriction. The leverage comes from something more subtle, the ability to expand or slow supply faster than competitors can respond without breaking their own industrial base. That asymmetry is the core of it. At this point, a counter-argument usually appears, that China is also vulnerable here, because oversupply destroys margins domestically too. That's true. In fact, it's already visible in periodic profit compression across the sector. But vulnerability and leverage are not opposites. Sometimes they coexist in the same structure. The question is not whether losses occur. It's who can survive longer while they happen. And China's system is designed, intentionally or not, to stretch that time horizon. There's also a second layer emerging now that most commentary underestimates: export diversification pressure. As Western markets begin to respond with tariffs or local content rules, Chinese firms don't retreat, they redirect. Southeast Asia, Middle East, parts of Africa, absorbing surplus capacity through new trade corridors. That doesn't eliminate tension, it redistributes it. Which brings us to a more uncomfortable realization. Solar is no longer just part of the energy transition. It is part of the global adjustment mechanism for industrial imbalance itself. And if that's true, then every new gigawatt installed is also a small recalibration of who absorbs the cost of that imbalance. There's a point here that keeps nagging at me, though. If the world is structurally dependent on a single country's cost discipline for its clean energy transition, at what point does cheap energy become a form of locked-in bargaining power rather than just a consumer benefit? Next part, we'll look at what this does to long-term security thinking, especially when energy systems start inheriting trade war logic without anyone officially declaring one. There's a moment in every industrial system where people stop asking whether something is working and start asking who it's quietly empowering. Solar is entering that phase. Not because it failed, the opposite. It succeeded so completely on cost that it started to reshape energy security thinking without ever being formally invited into that conversation. And that creates a tension most governments are still trying to name properly. On paper, diversification is happening. The United States is trying to rebuild domestic capacity through the Inflation Reduction Act. Europe is pushing strategic autonomy language into every second policy document. India is scaling its own production base under schemes like the Production-Linked Incentive Program. But if you look at the physical flow of components, not the policy language, the center of gravity hasn't moved much. It has thickened. The polysilicon bottleneck still sits heavily with firms like GCL Technology Holdings and a small cluster of upstream producers inside China. Wafer and cell manufacturing still scale fastest inside the same ecosystem. Even when final assembly shifts abroad, the upstream dependency often doesn't. That separation between where something is assembled and where it is structurally enabled is where most policy analysis becomes misleading, because control doesn't sit at the last factory. It sits at the constrained input layer. Now here's where it gets uncomfortable for Western strategic planners. Energy security used to mean redundancy, multiple suppliers, multiple routes, multiple storage buffers. But solar changes the shape of redundancy. It turns it into price exposure. If your cheapest decarbonization pathway depends on a global price curve set largely by one industrial system, then your diversification is no longer about supply. It's about tolerance. How much price volatility can you absorb before your energy transition slows? That's the real question sitting underneath subsidy debates and trade disputes. And there's another layer quietly forming alongside it: industrial data dependence. Every large-scale solar deployment feeds forecasting models, grid balancing systems, and long-term energy planning tools. Those systems assume continued cost decline or stability based on historical Chinese production behavior. If that behavior shifts, even slightly, the assumptions embedded in national energy models start to drift away from reality. Not catastrophically, not suddenly, just enough to misprice future infrastructure decisions by a few percentage points. And in energy systems, a few percentage points over 20 years is not noise. It's entire power plants. There's a common rebuttal here that deserves attention. Some argue that China's dominance is temporary, that as Western fabs scale and supply chains localize, the imbalance will correct itself. That may be partially true in assembly, but upstream correction is slower, much slower, because it depends not just on capital, but on refining process knowledge accumulated over decades of iterative scaling. That kind of learning curve is not easily replicated through subsidies alone. And even if parity is reached eventually, the transition period itself matters more than the endpoint, because geopolitical leverage doesn't require permanent dominance. It only requires sustained asymmetry during critical transition windows. Which brings us to a more subtle shift. Solar is increasingly being treated not as an industrial sector, but as a strategic buffer asset, something between energy infrastructure and trade leverage. Not officially, of course. No government will frame it that way publicly. But behaviorally, that's what is emerging. Tariffs, localization mandates, friend-shoring policies, they all point toward the same underlying instinct: reduce exposure to a single pricing architecture. But that instinct collides with climate timelines, because slowing deployment to rebuild domestic industry comes at the cost of emissions targets. And accelerating deployment increases dependence on the very system being questioned. There is no clean resolution between those two pressures, only trade-offs that get politically rebranded. And here's where the story stops being about China alone. It becomes about what happens when decarbonization pathways are built on infrastructure that is globally optimized but politically concentrated. At that point, the question is no longer who makes solar panels. It becomes who has the ability to slow or accelerate the world's energy transition without issuing a single directive. And I don't think most governments are fully prepared for how uncomfortable the answer to that might be. My view is simple. This isn't a solar story anymore. It's a control of speed story. Doubt I keep coming back to. Can China actually sustain this margin compression advantage indefinitely without internal financial strain eventually forcing a recalibration? Prediction. Over the next decade, solar stops being treated as a climate technology category in policy documents and gets reframed as critical infrastructure security. Not because it changes, but because everyone else finally realizes what dependency on its price curve really means. What's coming next isn't a clean break in the system. It's a split screen. On one side, you already see the outline of a parallel solar ecosystem being built in the US and parts of Europe, heavily subsidized, politically protected, structurally less efficient. Companies like First Solar are expanding domestic capacity, not because they can match the lowest global cost immediately, but because governments are starting to treat price as a strategic variable, not just an economic outcome. On the other side, the existing Chinese-centered system keeps doing what it has been doing for years, refining costs downward through iteration, scale, and internal competition that doesn't need to be explained in policy language. It just happens. The uncomfortable part is that these two systems don't really converge anymore. They coexist. And coexistence, in industrial terms, usually means friction that never fully resolves. There's a temptation in Western policy circles to assume this will settle into balance, a kind of managed pluralism where each bloc supplies itself. But energy systems don't respect political symmetry. They follow cost curves, material constraints, and time delays in capacity expansion. And right now, those curves still tilt in one direction. What makes this more complicated is that solar is no longer just about electricity generation. It is increasingly tied to storage systems, grid software, and AI-driven demand forecasting. Data centers are quietly becoming one of the fastest growing electricity consumers globally. That demand doesn't just need energy, it needs predictable energy pricing over long horizons. Predictability is where control becomes invisible. Because if one industrial system consistently sets the lower bound of global solar pricing, it indirectly shapes how aggressively others can scale AI infrastructure, electrified transport, and industrial decarbonization. Not through direct restriction, through economic gravity. And gravity doesn't need intent. There's also a technical shift worth watching. Efficiency breakthroughs like tandem cells and perovskite layers. On paper, they promise to reset the competitive field. In reality, they often amplify the same question: who controls mass production at scale, not who discovers the next lab efficiency record? History in this sector is already clear on one thing: innovation without manufacturing depth doesn't hold pricing power for long. So even if new technologies emerge, the question remains whether they reinforce the current center of gravity or genuinely redistribute it. Now, I don't think this story is about permanent dominance by any one country. That framing is too static for a system that changes through cycles of overcapacity and correction. But I also don't buy the idea that this is a short-term imbalance that policy alone can neutralize. Because what China built in solar isn't just factories. It's a compression mechanism, a way to repeatedly force global price expectations downward faster than others can build alternative capacity at scale. That mechanism can weaken, it can fragment, but it doesn't disappear quickly. My view is this: the real battleground over the next decade won't be who produces solar panels, but who sets the reference price that everyone else has to justify their existence against. Doubt I keep returning to. If Western economies succeed in localizing enough production, do they actually regain autonomy, or do they just create higher cost parallel systems that still benchmark themselves against Chinese output in everything from subsidies to investment returns? Prediction. Solar stops being discussed primarily as an energy technology in strategic forums and starts being treated like a reference infrastructure, similar to shipping lanes or currency benchmarks. Something that doesn't just supply power, but silently anchors how entire economies calculate feasibility. And that's the shift most people miss. Not who leads production, but who defines the baseline that cheap energy is measured against. Because once a baseline becomes global, even competitors end up negotiating with it, not replacing it. Anyway, if you've watched this far, I'm curious where you think the real constraint sits: technology, policy, or something slower that neither side can easily accelerate.